In this episode, we're perfecting AI hide and go seek with EQS, the environment query system. Hey guys, welcome to today's episode, and I am particularly excited for this episode because, to be honest, going into this, I was dreading EQS. When I first started playing with AI about a year and a half ago with EQS, I was all over the place. I just couldn't figure it out. And just in prepping for this episode, I think it finally began to come together for me. So if you don't get this right away, I totally understand. But over the course of this series, we're going to be using EQS a lot for our AI behavior, so I think you'll get a sense of it over time. But basically, EQS, the environment query system, it's exactly what it sounds like. It queries the environment for information. Now, in order to query the environment, we have to give EQS a specific location in the environment. But then, based on the location that we feed it, and it could be the location of a target, a threat, a boost of some kind, then EQS can do an environment query, basically a calculation. But based on that calculation, it can spit out any number of locations that our AI character can then act upon. So an example in today's episode is we are going to feed EQS the location where our AI character lost line of sight of its target. And then based on that location that we feed it, EQS is going to determine, okay, this is the most likely location that our target is actually hiding. And one quick thing to note is that I am cheating just a little bit with EQS in this episode. If you remember from previous episodes, it takes 4 seconds for our AI character to actually lose line of sight. So when we feed EQS the location where it lost sight of its target, it's actually the location 4 seconds after that. But honestly, I feel like that's fair because as the third person character, we cheat a little bit too, right? We can kind of look around corners, we can zoom out. So I feel like this just evens up the scales. So for our key concepts today, it's all revolving around EQS. In the description below, I've got links to some good resources if you want more information on this. And a simple way to think about these 3 concepts is that the system is the totality, the query context is the input, the what and the where EQS is actually looking. And the environment query is the how it generates that output that our AI's behavior tree is going to use. So let's get to it. So first things first, just make sure you have EQS enabled. And although it's an experimental plugin, it's been around for a while and I'm confident it's working pretty well. So it's under settings and then plugins. And if you search for environment, and it's actually the environment query editor, just make sure that this is checked. And if you need to, restart. And so now we're going to create 2 new blueprints that are going to serve as the basis for our EQS query. And so I'm going to go back to the content drawer and to the AI folder that we started 2 episodes ago. And I'm going to create a 3rd folder here, a new folder for EQS. In this one, I'm going to give it a teal color. So let's set a new color over to teal. That looks good. All right, so we'll go into that EQS folder. In our first one, if I right click, we're going to go to Artificial Intelligence Environment Query. And this is going to be EQS Find Target. But the next one's a little weird. So we're going to right click, we're going to create a new blueprint class and expand all classes here and then search for ENV Query. And we want our parent class to be the Environment Query Context Blueprint Base. Select that. And this one is going to be an EQC, an Environmental Query Context, Get Last Known Target Location. And the way I'm thinking about environmental query contexts is they allow us to get the information that we're then going to pass into the environmental query itself. So this is the input for this, and then this outputs into our behavior tree. But now we need to go into our Blackboard that we started 2 episodes ago because we need to make some updates to our Blackboard variables. So I'll go into that. We're going to create a new key, and this is going to be a vector. And this is going to be a long name I'm going to give it. It's going to be the current movement goal location, last known target location. And the second new key we need is going to be a bool. And this is going to be the previous target recently detected. And if this is true, then it's going to use EQS to move to our last known target location, but not directly to that target location. That's where the query is going to come in. It's going to calculate where our target most likely hid relative to that location. And as long as it was recently detected, it'll continue searching around in that area. But we're going to set up a timer for this. And once that timer expires, then the AI is going to go back to patrol mode. So let's go ahead and save this. And then we need to go in and update the adversary AI controller that we started 2 episodes ago. So I'm going to start in my has line of sight function here. And what I'm going to do is I'm just going to make a little bit more space here. And I'm actually going to copy these 3 current target has line of sight, paste them in right here. Connect this up here. And we just need to update that key. So that key that we just created is the previous target recently detected. So I'll just paste that in right here. And now we need to go into the clear sense target that we set up also 2 episodes ago. Because what's going to happen here when our line of sight expires, in addition to doing what it's already doing, it's also going to set the location that the target was last seen, and it's going to start that longer timer. So to start, I'm going to zoom out, make some space here. I'm going to copy both our Blackboard and make literal name here. Come over to the left, paste those in. And this is going to be just list our current target, and this is what we set up 2 episodes ago. And from the Blackboard, we are going to get value as object, connect up our key. And then what we need to check is our current target valid? And the way I'm going to do that is I'm just going to cast to actor, because all of our current targets are always going to be actors, whether they're characters, pickups, whatever. Now, if the cast fails, it's going to go right into here. But if the cast succeeds, that's where it's going to set this new current movement goal location, last known target location. So I can copy the make literal name here, paste it below. I'm actually going to right click on this just to rename, copy that entire string, just so I get it verbatim, paste it here. Get another reference to our Blackboard, paste that in here, and from the Blackboard, we are going to set the value as vector. Connect this up here to the key name, and then as actor, what we're going to do is get that actor location. So we're getting the location when line of sight expires, and then connect that up here. Now this is pretty messy, so I'm going to add in some reroutes. Move this out a little bit, connect this up here, and one more reroute. So this function is clearing the sense target, but when we're setting the last known target location, then we also need to have a function for clearing this after a certain amount of time. So I'm going to hit a plus sign here. We're going to create a new function for clear recently detected. And for this, I can go back to our has line of sight, and I can take this that we just set up and go into our clear recently detected and paste that in, because this is where we're going to set the bool to false. But we still need to call this function, and so where I'm going to do that is at the end of has line of sight. So we have this set timer by function name for our clear sense target, but now I'm going to do the same exact thing for our clear recently detected. So I'll connect this up here. And how much time it takes before it clears is really up to you, but what I'm going to do is I'm going to take the line of sight timer, and I'm just going to multiply this by, let's do 6. So that's going to be 24 seconds. And I'll make a little bit more space here. So that means our AI character will search around for 24 seconds before giving up and going to patrol mode. And the last thing here, just make sure to update your set timer by function name for clear sense target. So instead, we're going to get our clear recently detected function, copy that, and paste that in there verbatim. The very last thing I want to do here is all the way at the start where I have line of sight, I want to clear that timer by function as well. So I'll duplicate this one, because it's basically resetting that 24-second timer every time I get line of sight. And that's going to be clear recently detected. All right, that's looking good. Let's compile and save. Next, let's set up our environmental query context. So for that, go back to the content drawer, EQS folder, into EQC get last known target location, and we'll open the full blueprint editor. So with these environmental query contexts, we're either providing an actor or a location that we're going to run the query off of. And that's the input that I talked about earlier. And to do that, we need to override a function. And in this case, we're going to provide a single location, which is where our AI lost sight of the target. So the first thing I'm going to do here is make some space between these. And from the query or actor, we have to get our AI controller. And then from our AI controller, this is where we can get our Blackboard. So get Blackboard. And then from our Blackboard, we have to get value as vector. And the value as vector that we have to get is, if we go back to our AI controller, I'm going to go back to the clear sense target function because we have to get this literal name, our last known target location. Go back to our EQC, paste that in, connect this up. Now there's a possibility that when this function gets queried, this value as a vector isn't valid. And so we need to accommodate that possibility in this function. And the way we're going to do that is drag out a pin here and say, is it a valid AI location? Then I'm going to move over here, just make a little bit more space. We're going to branch off of this, connect this up to the branch. Because if it is a valid location, then it's very simple. We can just pass that in right here. So I'm going to put in a little reroute, move this up a little bit, and connect this up to the true. But if it's not a valid location, so if we don't yet have a location set where our AI lost sight of the target, what do we do? So I'm going to duplicate our return node. I'm going to connect this up to the false. And then instead of passing in this location, what I'm going to do is get a reference to our query or actor. We're going to get actor location. So this is our AI actor location. And then from this, I'm going to get a random reachable point. And for this, I'm just going to give it a radius of about 1,000. And the only reason we're going to need this is at the very start of play if our AI character has never actually seen and lost sight of the target. There might be a better way of accommodating that specific circumstance when we get up to that point in the behavior tree, but I found that this works just fine. So let's compile and save this, and let's go back to the content drawer, and now we'll set up our actual environment query. And the query graph looks very similar to behavior trees, but what we're going to do is from the root here, we're going to drag out and get points in a grid. And just to drag out a pin here and talk about this, so let's say for example that we wanted to get pretty close to the target, but not really close, because we wanted to be far enough away to use a ranged attack, but not within range of a close attack. So then the points donut would work well because it would find a location in a donut around the target. But in this case, we're just sticking with hide and go seek for now, so we're going to stick with the simple grid. And what this is doing is it's generating a series of points in a radius of 500 units around where our AI lost sight of its target. So with the radius of 500 and space between 100, so basically that's 100 points because it's going to be 10 by 10. And then we're going to tell this to score the points. So based on however we value those points, those 100 points around the target, we can score them to then allow the behavior tree to pick a specific point. So instead of generating those points around the querier, what we want to do is we want to generate them around our last known target location. That's the context that we just set up. And so the way I'm thinking about this is pretend you're the AI. So we're generating a bunch of points around where the AI lost sight. Now, realistically, what we would want to do to find the target is we would want to pick a point that's outside of line of sight of our AI at that point, because that would be a logical place where the target would be hiding. So the way we're going to figure out if each of those 100 points is outside of line of sight is we're going to right click here and we're going to add a test. So the test is going to be a trace to each of those to see if it's out of line of sight. So we're tracing from the 100 points to the querier. The querier is the AI character. And if it hits, that means there's something blocking from that point to our querier, which is the AI. That means that point is outside of line of sight. And if I select it here, what I recommend doing is expand advanced here. And under context height offset, I recommend adding 50. And the reason I recommend doing this is because our querier, the capsule component, it's really at about waist level of the querier. And 50 is adding 50 centimeters basically up to their eye level for that querier, for that AI character. We want it to realistically reflect hiding places from where our AI character's actual eyes would be. And this is a bool match, so it's only going to return those that actually have a hit. But then we're going to add another criteria, another test onto this. And that test is going to be a distance test. And the reason we're adding this is because there could be, out of those 100, there could be 30, 50 points that are all out of line of sight. So we need to give the querier, the AI character, a preference in which of these points they prefer. And the way they're going to choose that preference is the distance to querier. And for this, we're going to score those points based on the distance. So instead of filter and score, it's going to be score only. And there's a lot of settings in here for each of these tests that, quite frankly, I haven't fully explored yet, but we're going to get into it in a lot more detail over the course of building out our AI. One thing to note is that the order in which you put these tests is irrelevant, and the first thing that it does is it looks at all the filters. So any of these that are just filters, it looks at those first. And the reason for that is to narrow down, basically to filter out all the points that are not going to need to be tested. All right, if you got all that, if you got the simple grid, if you got our 2 tests, then we are ready with our first environmental query. So we'll save this, and now we got to go into our behavior tree because we need to update our behavior tree with EQS. In last episode, we created 2 branches of this. So we have the ability to follow our target if our target's in line of sight, whether or not our target's in the air or not in the air. And then the right-hand side of this is patrolling when we don't have a target location. So we're going to do something in between these two, because in that case, our AI has recently had line of sight. It lost line of sight, but now it's trying to reacquire the target. So I'm going to space these out a little bit, and this one over to the right. And from our adversary AI root, we're going to do a new sequence node. And this one is going to be called informed search for player. And then in order to take this sequence node, we're going to add a decorator. So right click, add decorator. It's going to be a Blackboard decorator. And if we select that decorator, then we're going to change that to, instead of the Blackboard key of self actor, it's going to be a previous target recently detected. And I can change the name of that decorator to recently detected target. And I'm also going to set this decorator to observer abort self, meaning if we reestablish line of sight, so if this comes into play again, it's going to abort this particular chain. Now within this sequence node, we're going to do 2 things. We're going to run the query, and then from the query, we're going to move to the appropriate location. So I'll drag out and I'll say run EQS query. And we have to update 2 different things here. So under EQS request, we have to update our query. It's going to be the EQS find target. But the other thing we have to update is our result Blackboard key. So once we run the EQS query, where are we saving that data? And so our input for the EQC was our last known target location. So I'm just going to update that same thing. So I'm going to go to our Blackboard key here, and we'll choose our current movement goal location, last known target location. So basically it's going to input this data when it loses line of sight, and then it's going to output and save it to that same variable. And then once we have our current movement goal location, last known target location, then we can just do a simple move to. So I'll drag out, we'll do a move to, and change the move to Blackboard key to current movement goal location, last known target location. Move this into position. And the reason I'm going to do that is because at first it's going to move to that location. And if it doesn't find its target, then it's going to run this again. It's going to find another location in that same vicinity. And it's going to do that within the 24 seconds based on the timer that we set. And once that timer runs out, then it's going to give up that particular search. It's going to go back to the patrol sequence. But I want to be able to update this location by observing the Blackboard value here so that if it runs the EQS query again, it gets a second location. And the same thing actually goes for the patrol sequence. So I'm also going to select the move to here, observe Blackboard value, same thing. And now one last thing. So back to the run EQS query. So we have this run mode here. I just want to talk about this briefly. So what it's doing is out of all those points that fit the criteria, it's going to score all of those. And then it's returning this run mode. It's returning the single best item. Now we could say instead, return a single random item from the best 5% of all points, or a single random item from the best 25%. So if you wanted to randomize the AI behavior a little bit, I would choose one of these. But I found that the single best item, basically the furthest distance away from that location that's still outside of our AI's line of sight, I found that that works best. So if you've got all that updated for our EQS query, if you got the move to observing Blackboard value checked, then we are all set to test this. Save our behavior tree, and let's go ahead and test. So the first thing we're going to cover in testing this is how we can turn on EQS debugging. And to start, we're going to turn on AI debugging tools in general. And to do that, it's just the keyboard button apostrophe. And you should see all that pop up. Now, if we look at in the top left corner there, we got AI, behavior tree, and EQS is not turned on. Neither is perception. And so to turn on EQS, I just got to use my number pad. So number pad 3. And now EQS I see is lit up green there in the top left, and it is turned on. Now, the other thing you need to do in order to troubleshoot this is make sure you have your AI character selected in the outliner, in the details panel, because only with the AI character actually selected do you see the debug information for everything you toggled on. All right, so our AI character, he's just struggling over there. He's stuck. And immediately after this, that's the last thing we're going to do in this episode is how to solve the stuck character issue. But it gives us ample opportunity to test EQS. So let's run over there. So now he sees us. He's got line of sight, and now let's get out of line of sight. So I'll hide behind these rocks over here. Yeah, so that was EQS right there. So each of the points that are outside a line of sight, they're all scored, and you see the scores there. And then you see a winner over here on the left, the winner 2.0, because that's the highest value target. It's the furthest distance away from our AI. Now he just did another EQS trace. You saw the blue ones. The blue hits didn't qualify because the blue hits were within line of sight. It's only the green hits that were outside a line of sight that actually qualified. And now our AI, well, he's got me. And just like we did 2 episodes ago, if EQS isn't even firing for you and you're trying to figure out why, make sure you've got your behavior tree up and you can actually watch your AI character following that. So I see he's keeping line of sight for me, but I'm going to go out of line of sight here. And now that I'm out of line of sight, now it ran the EQS query and now it's going to move to. So he's going to see me in just a second here, then it should interrupt. Yep. All right, so now let's solve the AI getting stuck issue, because this is still happening a lot. I know it's uneven terrain, but I want our AI to be smart enough to navigate unusual terrain. So the way we're going to handle this is we're going to build off of our adversary AI character updates that we started last episode. So for that, I'll go back into our actual adversary AI character, and we'll go into the overall jump and movement check function that we started last episode. And I'm just going to add another sequence pin here. So to handle the AI character being stuck, what I'm thinking is we're going to run this check every 0.3 seconds because that's when this function runs. And if the AI character's location is within a certain distance of their previous location, it's going to increment a counter. And then if the counter gets beyond some threshold, then our AI character is for all intents and purposes stuck. And if that happens, then we're going to force a change in target, or at least the target location. So the way we're going to assess whether or not they're moving, or if they're not moving, or moving-ish, like they're stuck but not moving a lot, is we're going to start with our character movement component. And then from this, I'll drag out a pin, I'll get our velocity. Scroll down to the bottom here, get velocity. And specifically what I'm focused on with the velocity is the vector length of the X and Y. And then from this, drag out a pin, and we're going to check to see, is it less than, let's say, 30? Because if it's less than 30, they're barely moving. So I'm going to move this over a little bit. We'll drag this out to a branch node, connect up 3. And here's where we're going to create a new variable for the stuck counter. So I'm going to hit + here. We're just going to call it stuck counter. This is going to be an integer. Now, if it's less than 30, what we're going to do is we're going to take that stuck counter, get, and we're just going to increment it. So drag out a pin and just say increment. Connect up the true. Increment just means up at 1. And if this is false, that means our character is moving. So I'm just going to set our stuck counter back to 0. So now come over here to the right. And if our stuck counter is, let's say, greater than 1, so I'm only going to give it 2 tries before it considers itself stuck. then branch. And the first thing it's going to try is it's going to jump. Now that's probably not going to work, but I figure jumping ain't going to hurt. But the next thing is we are going to change the location that it's moving to. So for that, I'm going to right click here. We're going to get our AI controller reference, get AI controller reference. And we set that up 2 episodes ago. And from there, we'll get our Blackboard. So get Blackboard. And from our Blackboard, we are going to set value as vector. Connect this up. And we actually have to do this twice because there's 2 different vectors we might need to change. So if I go to adversary AI controller, if I go to the has line of sight function, and if I go to the clear sense target function, so this is the first one, the one we just set up this episode. So I'm going to copy that, come back to our adversary AI character, paste that in. That's going to be our key. Now the question is, what are we updating it to if our character is stuck? And for that, I'm just going to pick a random location, but I'm going to keep that location close by for this last known target location. And the reason I'm keeping it close by is that way it's still within that general vicinity where it's searching around. So once again, I can get a reference to our AI controller and our Blackboard. And from here, I can get value as vector. And the value we're getting is again this, paste this in, and we'll drag out from here and say get random reachable point and radius. And that radius is only going to be 100. And then I'll move all this over and connect this up. But now we got to do this one more time. So I'm going to select all this stuff, copy, come over here to the right, paste it in, connect this up here. And this is going to be for the other vector we could be moving to, and that's our patrol location. So for that, I got to go back to our Blackboard and specifically back to the Blackboard here, and then I can right click here, rename, get that exact vector name, and then back to our adversary AI character, paste that in, paste it in here. So I'll compile and save this, but the last thing we're going to do is over on our event graph. I'm going to go back to the front of the event graph because we have to do something for the on-tick behavior that we set up also 2 episodes ago. So I'm going to take our branch and our add movement input, our get control rotation, get forward vector, move these out a little bit, move these 2 down a little bit, because what we're going to do is an or statement here, or Boolean, and then hook this up. Because if our velocity is greater than 3, then we're adding movement input, but we're also going to add movement input if our stuck counter is greater than 1. Greater than 1. Connect this up. Compile and save this. And I just want to mention, so back in our behavior tree, so back to the behavior tree, that's why in this move to location, I said make sure to check observe Blackboard value, because if our AI character gets stuck, then it's going to change the location based on what we just set up. And then this or this will be updated. Actually, both of them will be updated, but whichever one is being taken, if we're observing the Blackboard value, then it's just going to go to that new location. And for these 2 over here, we already have that checked, so we should be all set. One last update to our behavior tree. So instead of abort self for recently detected target, I should have set this to observer aborts lower priority. And although this isn't going to be relevant this episode, it is in the next episode, because in our next episode, we're going to do AI perception hearing. And what's going to happen is if our AI is patrolling and then our AI hears the target, so it's not actually going to get a target because it's just hearing the target. It's not seeing, it's not confirming the target. But we are going to update the last known target location based on the sound. So in that case, we want to interrupt patrolling and we want to go right back to move to the last known target location. And we could also run the EQS query too, because if you hear a sound, it's kind of a generalized location, and the EQS query is going to return then a generalized location kind of further away from the sound. But all that's going to come together next episode. So if we got everything saved, let's test again. All right, he's got me. So let's ring around a rosy a little bit. And what you want to test for is, does our AI character ever get stuck? And if he does get stuck, does he change direction? Does he move to a different location that's a realistic, a good location? Obviously, if you don't have an air and speed boost, it's going to be a little bit more difficult to win this game with the AI, but maybe the challenge is worth it. So to finish out the episode, as always, let's clean stuff up. So let's go back to our BP adversary AI character. Let's go back to the jump and movement check function. We'll collapse all of this down to a function. And all of these are checks, so we're going to do the same kind of thing. So collapse to function, and right click over here, rename. This is going to be our is stuck check. And we'll also categorize it under AI movement. Compile and save. So that concludes our episode for today. And in our next episode, we're finally turning on AI perception hearing. So right now, this character, he can't see me. So I'm just at the base of the cliff. He has no idea where I am because he can't see me. But the moment that I start to move, he's going to hear my footsteps. And now he's got me. So I hope to see you there in the next episode.